cryptocurrency and Bitcoin. We'll just try to get into this, how the blockchain technology was evaluated from which year and that. So the evaluation of blockchain technology having three pillars basically. One is the blockchain technology is a distributed system. So in that distributed system, to overcome from the problems of how to protect the data, we discussed the crypto part, which is involved in this blockchain technology, and then we'll try to see the economic models of your the blockchain technology. So in this, the distributed, the blockchain technology, the most important one is distributed systems. So in this distributed systems, to understand this distributed system, it is very much essential in order to understand the blockchain technology, which is basically using because the blockchain technology basically using this core part of your distributed system. So more precisely, it is a decentralized distributed system because there is no centralized what you call the control system, because every node in this distributed network can act as a creator and destroyer also. So these distributed systems are computing the paradigm whereby two or more nodes in this network, they can work with each other in a coordinated fashion in order to achieve the common outcomes, and it's modeled in such a way that end users see it as a single the logical platform. So in this, if you take the core problem of your distributed systems, a node can be defined as an individual player in a distributed system, or they can be any the organizations also. But here, all nodes are capable of sending and receiving the messages. And this is a peer-to-peer network. They connected to each other. It's a peer-to-peer network part. So nodes can be, in these nodes can be honest, faulty, or malicious, and have their own memory process to create the messages and receive the messages or sending the messages. So every node having their own processor and the memory, and a node that can exhibit arbitrary, suppose the arbitrary behavior is also known as, suppose if this node in the network is behaving arbitrarily, then that we call this node as your the Byzantine nodes, or malicious nodes, or faulty nodes, we call any misbehaving nodes. So this arbitrary behavior can be intentionally malicious, so which is detrimental to the operations of this entire the network. So generally, any unexpected behavior of a node on the network, that can be categorized as your Byzantine node. So this term arbitrarily the encompasses any behavior that is the unexpected or the malicious behavior of the network. So as said, what they need to in the distributed system, every node they can capable of creating the transactions in the blockchain technology or in the Bitcoin technology. So as we saw this example earlier also, so they can create, or if they add any of the transaction in that block, it must be known to every other node in the network. So the other nodes in this network, they need to agree on this new block. So to agree on this new block means it must undergo through the crypto process, whether this is valid or not first. So every node go and check whether this is a authenticated user's block or not. So authenticity will be, or originality will be checked out. And if it is agreed, this new block is agreed by every node in the network, then the classical distributed consensus problem comes here. So how to distribute this one then? So a classical distributed consensus problem. So how it will do? To get agree, the transaction which is created by a node 2 in this distributed system, majority of your network nodes, they must accept it. So to do that, if in distributed consensus agreement is required, basically. So what happens if the users, they come together in the blockchain technology, and suppose there is two possibilities, that one group of people, they want to go with the pizza, and one group of people, suppose they want to go with the burger. In that case, they will announce this in the network, in the distributed network, that shall we go for the pizza? And some prefer they want to go with the burger, okay? And then from this, how many nodes are there in the network? So majority of the nodes which are accepting the idea of their information which is exchanged, based on that, they all comes to an agreement that will go with certain process. So majority of the nodes in this, they want to go with the burger. So majority of the nodes, they agree to go with burger. So they all are comes together that we'll go for the burger process. Yes.
If there's no centralized place for all of their desires to be cataloged, how does each individual know that is the consensus, that the consensus is burger?
Yeah, that is what, because there is no centralized process here. In distributed one, everyone can act, right? So suppose if you are giving one idea that we want to go for the burger, suppose.
Yeah.
So you create that message and you will distribute in the network.
Yeah.
So how do you distribute? We'll do the broadcast in the network. So upon when you broadcast it, that will be received by every user in the network. And at the same time, suppose the Northern is also generated one message that no, we'll go with the I want to go to Pizza Hut, whether you want to come or not. So in this class, suppose we announce. So that is also received by every user, correct? And in that, the opinion says that you both are the senders now, right, in the network. Okay. So remaining are also participants in that. Okay. So out of that, if these three guys they accept, we'll go with the burger. So 3 plus you, 4, agree. And if those these two students they agree with go with pizza, suppose. 2 plus 1, 3. So majority is 4. So then that majority information, majority of the nodes in the network go with the burger. So then the remaining are also accepted. So this agreement we call the consensus. So in that consensus, in distributed one, how it is means based on majority. Yeah. So that is required. So how can we make this decision in a distributed way means? So that information will be sent to the every node in the network. Okay, that shall we go with the burger, and similarly that will be done by another user. Suppose Bob will also send that information to everyone, and then everyone having the option of pizza as well as burger. Everyone is having the updated information of pizza and burger. Pizza announced by the Bob, suppose, and the burger announced by the Alice, suppose. So everyone having the pizza burger information. So then what they will do, how to decide then how to go. So because the Alice says that you told pizza, then the Bob says that nope, I told burger. Why? Because because here the Bob becoming the non-repudiator, I mean the repudiator. So it should not be there. So for that, what? Everyone needs their identity. So if their identity is there, with their identity, they whatever the message that shall we go for burger, that message encrypted with their private key only, right? So that will give the authenticity and non-repudiation. So to achieve that one, this process gives a lot of problems. So how to achieve that one means it requires the second concept, second pillar of your blockchain technology, that is for crypto. So for crypto, we have seen in distributed consensus, we have seen this history that in 1985, the the authors, the Fisher, Lynch, and the Peterson, they developed one, the consensus, which is consensus is impossible in a fully asynchronous system. In fully asynchronous means in that distributed system they are using the private key and public key in asynchronous system. So even with a single crash fault, okay, in any of the users suppose get fault, in that case they can't ensure, they can go with this system, but these authors can't ensure the safety and liveness together in that distributed consensus system. So what is safety? The safety means it must accurate the process. The process will yield the correct output. Process will yield the correct output. So as we saw in the previous slide that the Bob is saying that no, I told pizza. If you recall that, when the Alice is asking that you told pizza, then the Bob is denying that no, I told burger. So there should be a correctness is required, that is your liveness is required. So that is that can't ensure their concept not ensure the safety and liveness. So in this liveness means the output will be produced within a finite amount of time only, not take much time. So within a finite amount of time means in a distributed network, if you take a distributed network, it's a peer-to-peer network, every node is connected to every other node. Suppose in this case, the bandwidth which is there in between your node 1 and node 2, if it is slower, then if the information which is created by one which goes through this network, I mean slower bandwidth, and updated by your node 2, it may take more time because of the delayed transmission that meanwhile it can get another information from another user. So that is the output will be produced within time frame. If it is not there within time frame means that particular information should be discarded from the network, outdated information it is. So that will be eventually the termination process. So in 1985, as mentioned by these three authors, later on to achieve the non-repudiation, the Lamport started talking about the Paxos. And the idea of this Lamport, which supports the safety, that is the correctness of your the blockchain technology, but not liveness, not address the liveness in his article. So in 1990s, everyone was confused about correctness and Paxos. So after going through a lot of research on that, in 1998, the Paxos got published in ACM transaction on a computer system and addressed the some of the issues that what is the difference between the Paxos and the correctness. So in 2001, again the authors FLP Impossible paper that wins the DigiCash prize because people started talking about the distributed systems from 2001 onwards. So in 2009, Zookeeper released the another paper that service for managing the distributed applications, how to manage them. And based on that research in 2010 onwards, different types of distributed consensus algorithms were released. So that is your multipaxos, your raft algorithm, your Byzantine fault tolerance, or your protected Byzantine fault tolerance, and the recent algorithms are also included in that. So based on these concepts, how it leads used into a cryptocurrency, that is an automated payment system which is having a few properties in the cryptocurrency, that it is inability of the third parties to determine the pay, the time, or the amount of payments made by the individuals in the network. And in this automated payment system, it is ability to show the proof of payment, whether it was really done or not. And it is this cryptocurrency payment system, it is ability to stop the use of payment media which is reported the stolen one. So from this concept, in 1983, as we discussed in the very first lecture, the eCash system introduced, which is developed by your Devin Chon, which we discussed. There they simply use the blind signature to get any coin from the the bank. The sender can send their identity to bank along with the money so that they can get one digital coin, and that digital coin can be used for the exchange of your Alice and Bob term, which we discussed in the very first lecture of this. So in this blind signature, what happens, whatever the identity is there, that the information of any individual is there, that information is simply doing the digitally signed, the drag operation. So in this, you are having the to and fro and some information inside this. So then they want to get your credential that is verified by your banks, but do not want to reveal the text of your letter. They just check who is the sender, who is the receiver of that. But what is there inside is, they don't reveal that. So in this blind signature, whatever the message is there, that won't go inside, but they can simply check who is the sender, who is the receiver of that. And then based on that, they will get signed OK. But inside what is there, it is not known. That concept is blind signature. So the official has verified the credentials of the persons who has written it, but have not seen the main message in that. So the official does not know the actual message. They only knows that person X has sent some message to some person Y. This is what we have seen in the eCash and the DigiCash that we discussed, right? So then, in cryptocurrency, what is needed in cryptocurrency means, the most important one is the amount of your payments that made by an individual, that is, even the banks will not be able to track it. So there it requires the complete distributed platform for the cryptocurrency exchange. So for this, the cryptocurrency exchange part, in the complete distributed format, it goes through the history of the different papers which addressed, that is the DigiCash mechanism, and then the way they publishes another famous the anonymous distributed electronic cash system called the BitMoney, and another user, the authors, that Nick, that described the Bitgold concept. So some central in that say, he addressed that the participants solve the cryptocurrency puzzle that depends on the previous puzzles, like by following the hash chain function. So some central control still needs to verify that puzzle that has been solved correctly or not. That is not addressed by the user Nick. So then in eCash DZ, as we check, can we verify the proof of the puzzle by solving the distributed way? Means yes, by following the distributed consensus. So to go through the distributed consensus means the majority of the nodes in that distributed network, they must agree with certain rules and procedures. So what is the issue with this classical distributed consensus means message passing. So in that message passing, there is no need to identify others. They can simply, if they have the information, I just want to go to Pizza Hut, can anyone join? But they don't know whether their classmates are coming or others are coming. They don't know. But it should be restricted, right? Only the user's identity is required, who is sending and who is following them. So in this case, whether it works within a closed system or the open system. So if it is works in the closed system or open system, from that concept, as we discussed in 2008, one white paper got floated in the internet, that is your Bitcoin peer-to-peer electronic cash system. And after that, the many of the organizations and the individuals, they started doing research how it is possible. So that is based on the consensus. So in consensus, the consensus can be an open environment. So in that paper address that, in that white paper, they address that there should be a hash chain as we discussed, and the puzzle solving as a proof that the payments has been done. So that comes from your BitGold, which is authored by the Nick. So combining these two and combining a coin mining is an open peer-to-peer system. Coin mining means any one of the node in that network, they should take responsibility to verify these transactions in the network and generate a new block. So the task who is performing by this, the verifying the blocks and joining the blocks and creating new blocks, we call the coin mining in the peer-to-peer setup. So to do that, what is the use of them? So for this proof of work, the Nakamoto consensus was adopted in this distributed consensus model. We will discuss this one by one in detail with the some of the examples. And then in this proof of work, this is the key success of your distributed the systems. So what is that? The key is they give more emphasis on liveness as well as the safety. So when you talk about the distributed systems, the safety and liveness is more important. Safety is there should be a correct output. Correctness should be there. Liveness means the output of your transaction should be within time. So to do this, it requires some mechanism that should be performed by any individual in the network. We call that user as your miner of your system. So from there, the participants may agree on the transaction that is not a final one in the chain before the accepted by everyone. So there, in this proof of work, have not coined the term blockchain until 2008. But after combining the hash chain process, the puzzle solving, and the coin mining that gives the proof of work, so then the new consensus came into the system, and after that, the actual work started. Doing the research on this paper, which is the white paper, which is posted in the internet. So in 2011, the Litecoin got introduced. Then in 2015, for this blockchain technology, the Ethereum network went live. Then sometimes around 2016, the term blockchain got popular. And after that, many of the organizations, they started working on this blockchain, the technology background. So the economics behind this blockchain is Bitcoin mining. Who is mining? Why they wants to mine means if they do, giving more work to the distributed network, they will get some price for their work. So you can earn money by solving the puzzles. Solving puzzles means creating new blocks. Whatever the previous blocks are there, they all are verified. If any new transactions are there, new transactions added in the block and new block will be created. That new block will be distributed among all the nodes in the network. Once everyone is agreed, then that will be published. Once it is published, then it is the responsibility of every node in that network to pay some money to the miner who created a new block. So for that, if everyone agrees that okay, we can pay for any new block creator, so then everyone trying to do that operation. Okay, to get money, I will also try to create the new block. But in that, what happens if there are 10 users are there in that network? Out of 10, if 3 or 4 are they are actively participate to create the block, suppose to get money. So in that case, if 3 are trying to create are doing the mining job, in that case, user 1 may create the mining new block and distribute the same work done by user 2 and user 3. But because of time delay or because of processor delay, user 1 become winner and user 1's block is accepted by everyone because user 2, user 3 having the same transactions in that block. So user 1 will get money. So that's the process to solve the interest in the someone. Okay, so that is the one. So the blocks are created, and why they want to do means the new blocks means new block is created means the hash will be there, data field will be there, and previous hash function is there, and that will be accepted by every user. Then they will get money. They will get the money, right? So we call this as your miner, Bitcoin, or simply we call the miner of the blockchain. So then, if it is accepted, then that Bitcoin is distributed among the users in the network. Yes, please.
Is mining a zero-sum game where whatever the miner has gained must come at the expense of those in the network, or is it something that is created as a reward for them? Like we all agree, oh, you mine block A, so you get 1 coin.
No.
Or does user 3 say, all right, here's 1/1000th of a coin, and we go all throughout until you get your reward?
No, it is not like that. Every user in the network, they try to play their role to get money. Mm-hmm. That means if you created one block, I'm also created block at the same time because you are also having the same number of transactions in your block.
Yes.
I'm also having the same number of transactions. So we are working at the same time. Mm-hmm. And others may be busy, so they don't do mining.
Yeah.
So our both blocks are distributed. Mm-hmm. Then upon receiving these 2 blocks, your block may be received by every user in a faster manner than mine.
Yeah.
So then once they get my block, also they compare your block with my block. Mm-hmm. It's same. Mm-hmm. But who's transmitted first? Whose block is received? Yours. Mm-hmm. So they will give you some, the what you call the remuneration. Okay. So it is an agreement in the distributed system.
Okay, but it is part of their. I guess I'm just not understanding how the transfer from a bunch of users to one.
No,
user.
It is suppose there are 10 users are there. Mm-hmm. So for doing mining, there will be a pre-agreement that for every miner, okay, the mining fellow they get $10 for new transaction. That $10 is taken from all the 10 users. That means for if distributed to every user means every user has to pay $1.
Okay. Yeah.
Yeah.
Right. Thank you.
So that's the distributed concept one. So it is just to encourage the community to participate in the mining through incentives. So that the system goes on. Why means if any one node in the network suppose faulty or misbehavior, though they are free, they don't want to do. If there is no any compensation, then why should they spend their time and their process and their memory from the node? So to encourage everyone to actively participate, this is one consensus in the distributed system to achieve the decentralized the system. And this solving these puzzles that produce a new Bitcoin in the system, which is similar to the minting the new coins. So this Bitcoin network works like the Reserve Bank to regulate the flow of your money in the market, and but without the explicit governance for this. So if you take the popularity of this Bitcoin, as we said, started from 2012 onwards, it reached, the Bitcoin transactions are, reached somehow, but whereas your Ethereum transactions reached to the very maximum transactions after introducing this, the cryptocurrency population. So if you see the growth interest in developing the decentralized app, the Ethereum transactions are having more compared to your the Bitcoin transactions and your Litecoin transactions, which were coined in 2011, 12, and 13 onwards. So as we said that this Ethereum transaction was introduced late in 2016. Before that the Bitcoin and the Litecoin was introduced in 2011 and 2012. So the US cryptocurrency market, this is taken from the cryptocurrency market report. So there in 2020 to 30, of this market size may grow by from in 2010 it is 0.3 billion to in 2021 it is 1.1 billion, and it's go on increasing the market. So which one go on increasing means it is not Bitcoin transactions, it is the Ethereum transactions are go on increasing in this. So in this case, how this technology is distributed and used, in that Bitcoin technology or any crypto coin technology, the blockchain playing a major role after doing a lot of research on the base paper of your Bitcoin, that is peer-to-peer network. So the first version of your blockchain is used, that use of your distributed ledger technology, DLT technology, that to design the money of the internet, that is Bitcoin or any other cryptocurrencies. So I would like to stop this session here.